This video is going to be about factoring binomials. Remember, binomials actually means two terms. And specifically, we're going to be talking about the difference of squares formula. Now, I'll give you guys an idea of where the formula comes from. So for now, why don't we just multiply a plus b times a minus b. Remember, we multiply this using FOIL. So first we have a times a is a squared, then we have a times negative b, negative ab, then we have b times a is positive ab, then we have b times negative b is negative b squared. Combine our like terms, we end up with a squared. Now the negative ab and the positive ab cancel each other out, a squared minus b squared. Now, the difference of squares formula is just this formula backwards. So this tells us that this is equal to this. So I'm going to write that in reverse. So the difference of squares formula says that a squared minus b squared is equal to a plus b times a minus b. Notice that's just the reverse of what we just showed, so it must be true. So how do we use this formula? So we use this formula to factor binomials. Okay, so how do we do that? Well, step one is to identify a and b. We do that by writing the binomial as a difference of squares. In other words, a squared minus b squared. You just have to write it in that form. Step two, plug a and b into a plus b, a minus b. In other words, the right side of that formula. The formula right here. Okay, one thing I want to point out before I do some examples. There is no sum of squares formula. Okay, so if you ever have a sum of two squares, there is no formula to factor that. Let me give you an exclamation mark for that. That's really important. Okay, so starting with number one, we're going to factor the following. H squared minus 64. Now, step one says identify A and B. Identify A and B. So in this problem, what's our A, what's our B? Well, I can write this as h squared minus 8 squared. So it's a difference of squares. So that means A is h and B is 8. So if I put them in the formula, I end up with h plus 8 times h minus 8. And that's it. Okay, let's try another one. This is number 2. I want us to factor the following. 25t squared minus 144u squared. So we want to see if this is a difference of squares. So notice the first one is 5t squared, and the second one is 12u squared. So in this case, A is 5t, and B is 12u. So put them into our formula, we end up with 5t plus 12u times 5t minus 12u. And that's it. Okay, let's do a slightly trickier one. This time we're going to work with fractions. I want us to factor m squared minus 9/49. So I can write this as m squared minus 3/7 squared. So it is in fact a difference of squares, isn't it? Since 3 squared is 9, 7 squared is 49. I end up with m plus 3/7 times m minus 3/7. And that is my answer. So you can see that these are quite quick once you get used to using the formula. Let me try another one. Y squared plus 25. Now, before we try to factor this, let's remember what we said before. There is no sum of squares formula. So, can anything factor out of this? Nope. So this is a prime polynomial. There is no factorization that works. Really important to make sure that it says minus, because plus is not going to work. This plus right here tells us everything. Okay, so as a note, since I forgot to mention this, but this is always true whenever you're factoring, always factor out the GCF first. Always do that first before doing anything. Okay, so let me do another example. I want us to factor 24 minus 6x squared. Now notice that to begin with, this is not a difference of squares. Now, that doesn't mean we can't factor this, because notice there is a GCF. In fact, the GCF is 6. So that means I can pull out a 6. If I pull out a 6, we have left 4 minus x squared. Now notice that the thing we have left is a difference of squares. So according to the formula, this becomes 2 plus x times 2 minus x. We still have the 6, and so that 6 just came right down. And that is it. We're going to try a couple more. 3r squared plus 75. Now, even though this is a sum, notice there is a GCF here. The GCF would be 3. So I can take out a 3, and what's left is r squared plus 25. But notice now there's nothing more we can do because this is a sum of squares, and so this is my final answer. I do not write prime. The reason I don't write prime, we were able to take out a 3, right? So this is not a prime polynomial. Prime is when you can't take anything out, like number 4 was. Okay, final problem. This one will be tricky. You guys will see why. So it's going to be x to the 4th minus 1. Now, even though it's a 4th power is still a square, isn't it? In fact, this is x squared squared. So this is a difference of squares, right? And this is 1 squared. So this is in fact a difference of squares. So this becomes x squared plus 1 times x squared minus 1. Now before we say we're done, we actually have to look at this again, because notice the second one is a difference of squares again, isn't it? The first one is a sum of squares, so you can't factor that. But this one, I can write it like this. So this becomes x plus 1 times x minus 1. And this is x squared plus 1. And that's it. Okay, so I hopefully factoring a difference of squares is not intimidating anymore. In intermediate algebra, if you're in intermediate algebra, be sure to watch the other video regarding sum and difference of cubes. In beginning algebra, this is not as important. Thanks very much for watching. Hope it was helpful.